Thank you for that. And thank you for all the effort you put in pronouncing my name. I'm always grateful for that. So towards the start of the year, I found myself on this, OK, this doesn't work, never mind. This spectrum of choosing between should I have less JavaScript in my stack or should I have more JavaScript in my stack. And all of that kind of happened because I was put in place to figure out what should be the styling architecture for Primer, which is the design system that powers GitHub. So on the React side, we were trying to figure out what should our styling architecture be. And which is, I guess, a good point to introduce myself. I'm Siddharth. I work on the design engineering team at GitHub. Design engineering is kind of like a weird, we're in the design org, but we're an engineering team. So we do things like styling architecture and tooling and all of that. So while I was trying to work on this and trying to figure out what's the right spot here, why this was such a confusing or a hard project for me was because changing the architecture for just Primer React could actually change the architecture for the entirety of GitHub, React at GitHub. And I didn't want to be, I didn't ask to be in that position, and it's a hard position to be in. So just to take you back on why this is even a decision that we're making now, go back to 2015. I like how the previous talk also had like go back to 2013. I love that. So go back to 2015. Just to put in context, this Game of Thrones meme was 2015. It's been 7 years. The best movie of all time came out in 2015. And Drake gave us this amazing number. So also at the, wow, I should have played auto loop. I didn't do that. So also, Internet Explorer 11 is still a thing. Edge wouldn't release until later that year. And CSS variables are only a spec at this point. So only Firefox implemented it, which we'd come back to, pour one out for them. And you'd see that the last version of IE was actually in 2014. There were no new versions of Internet Explorer after that. So interesting time to be working on styles. So while we start on like the low end of, keep doing that. While we start on the low end of JavaScript, this is what writing styles look like. If you're building a button, you would put some styles, put some hard-coded color codes. And then if you wanted nesting or if you wanted variables, you'd just slightly go further along the spectrum and use something like Sass. So Sass is JavaScript. You compile it with Node Sass. It's written in JavaScript. And it was written in CoffeeScript, I think. And you get things like this, where you can nest things. It's a slightly prettier syntax. You can use variables. So you could put all of these variables in one file, manage it. It becomes easier to manage them. And then when React came along, you'd also use them in React, which was pretty cool. And the way most people were using React, you would create a component. You would put it in its own file. But then you would import it in a different component. So ta-da, React. And there was something very cool that we were doing then, which is almost without realizing, which is that we would import button into a page. And that would create this dependency tree for us, where we would know that page depends on button. And all of this could be statically analyzed by bundlers for tree shaking, for creating smaller bundles, and not just load all of the JavaScript together. So we were doing something really interesting here. But the same wasn't really possible to do with our CSS, because there was no real link between that button class and the button CSS. So even though you knew what components are being loaded, you didn't necessarily know what CSS is being loaded just for those components. You would end up loading a lot more. Of course, we went slightly further. Go slightly further? OK, we went slightly further with CSS modules. So a little more JavaScript. And what we could do is imitate, because it's not really happening, but we're imitating as if we're importing CSS into our JavaScript. And that gave us this nice dependency tree also for our CSS. So you could do smarter CSS bundling. You could do critical CSS pretty easily. You could purge unused CSS, all of that. Now, when it came to theming, because theming is also a big topic in design systems, with Sass, even though these variables are cool and you can create a bunch of, you can define these variables differently for different themes, all of this gets compiled at build time, not in the browser, because again, CSS variables wouldn't be a thing for a few years now. So you'd have to find a way of filling in these variables. And remember, theming is not just about light and dark. Theming is light, high contrast, like all your eyes just went. Sorry about that. Theming is about color blindness, so the different variants of color blindness, and do the same thing for dark as well. And the way to do that would essentially be compile all of these CSS files for every theme possible. So you'll have a light CSS, a dark colorblind CSS, a light Trinitopia CSS. And then you load a big chunk of CSS when needed. So a good solution at the time, and now we're like 2016, 2017, where React is booming, CSS variables are still not widely supported, people still have to support Internet Explorer, and this is where we decided, OK, let's dial slightly more onto the JavaScript side and use something like style components, because what we wanted was variables, and JavaScript already had variables. So this code would become something like this, where you're defining your styles inside of your JavaScript. And what that gave you is theme inside of your JavaScript. So then you could just do the nice thing with theme.color.button.foreground and pipe them in. Works really nice. And then, of course, you got destructuring, so code became prettier. There was a whole wave in 2017 where JavaScript just kept becoming prettier. Not really more useful, but like definitely prettier, right? Destructuring, arrow functions, bunch of really cool things. I mean, code aesthetics, I like it. And you wrap your application in something like a theme provider, and when you change the theme, it would trickle all the way down. So brilliant stuff. Now, something that always is kind of like a problem with JavaScript is that I added a OK, it's animated, sorry. So I added a foreground hover to my hover styles. But then just looking at this code, you can't really tell if the foreground hover exists or not in JavaScript. And the only way to know this is actually run this and see it in the browser. And of course, if it's not an object, if it's the last instance, it wouldn't even break on the browser. And then you'd actually have to check your CSS to actually see if there is a foreground hover and it did change the color or not. So decided just like slide slightly over to more on the JavaScript side, so you use TypeScript. And then you start getting, so you can't really use template strings anymore because you want more types, so objects type better than template strings, so object styles are supported. And then you start getting these nice things where if you type the theme, you get the squiggly in your browser and your CI, and it gives you a nice error. It's like property FG hover does not actually exist in theme, so there might be a problem there. Super nice. We got some linting. There's another thing that I don't know how many of you noticed. The border color is actually this. It says button.bg instead of button.border, and I made this error and didn't even realize it. But now that we're typing it, we get a lot of new squigglies that we didn't realize were there. So something like this, where you can actually make your style object smarter. And this totally depends on the rules of your own theme, where you can say something like theme.color.button.bg cannot actually be assigned to border color, because border color can only take these n number of styles which are meant for the border. So you can make them really intelligent, and then you ship these, and your application developers also use the same types. So you get a lot of linting, autocomplete, all of that for free. Another error I made here is the background color is in hover. I actually just accidentally dropped the hover, so it doesn't hover anymore. But it would catch these errors in a similar way. And with TypeScript, you also get a nice autocomplete. So I know that these are the valid tokens. TypeScript would suggest them to me when I do quick fix, and I can actually choose. So for example, this is a button. I'm going to use bg button hover. OK. gives you a break to really like process the contents of the talk. Let's see. So now when you're using these components on a page, you sometimes also want to customize them, right? So created the button, but when it's used in the context of a page, you might want to add some more styles. So for example, in this case, I needed some margin on the button. So the canonical style components way is wrap that button in style, and then you also get the theme, and you can customize it. It's good, it works, but it leads you to create a lot of components that are just one-off, on the fly, and not very pretty for code aesthetics. Remember, it's 2017-18. That's important for us. So we slide a little more onto the more JavaScript side. And this logo is of Theme UI. Theme UI is kind of what made this syntax popular, where you add an object onto your component. So instead of creating a new one, you can just add an object there. And it's called SX because it's trying to imitate the style property, style attribute, but it's not actually the style attribute. This gets compiled. This gets bundled inside. So what that looks like is inside my button component, I make room for another prop called SX. So the button accepts an SX prop, and it merges the styles with the SX. And because we have TypeScript, we can also type it the same. So you get all the validations, you get linting, you get autocomplete, and both of these get merged. So we've gone from less JavaScript to a lot more JavaScript, but we've got a lot of features along the way, like nesting, variables, theming, linting, the imports, and we've got a really opinionated autocomplete that I really like. So sounds like a success, right? Just to give you some context, there are around 4,000 until last week. It changes very quickly. There are around 4,000 presentational components at GitHub. GitHub, by the way, is primarily a Ruby app. So the React part hasn't really existed for that long, but there are a lot of presentation components. There are, of course, more React components, but there are 4K that use the SX prop and insert styles onto the page. So you can say it's a success, but it's kind of too big of a success because now we're seeing a lot of problems. So big style updates are slow. Because there are so many components, if you have a pull request with like thousands of files, doing a trigger on it which repaints the page, actually, it's noticeably slow if there are too many files. Collecting styles for server-side rendering takes a significant time. By significant, I mean it's like 10% of the server response time, which is a lot for just collecting the styles. And it's recently become even more trickier with streaming and suspense because you have to think about when is the right time to inject these styles into the browser because you don't want to accidentally take over the main thread. So started thinking about, can I add one more feature to this list and compile my CSS out? We're doing like performance problems. Our performance problems are mostly related to we're doing too much work in the browser on the user's device. What if we could do some of this work ahead of time during build or compile time? So my natural instinct is maybe I can write a Babel plugin or a Webpack plugin. Like just slightly more JavaScript will fix it, surely. And before I went on that, I looked around at the ecosystem, which I hadn't done in a while, and I found there are a few options that are there. So there's vanilla extract, which the idea there is that you write your styles in the CSS.ts extension. So you're writing styles like CSS, but you're writing it in TypeScript, and it's very strictly typed. So it's very strictly typed, which makes it very statically compilable, and then vanilla extract can actually pull this out into a CSS file ahead of time. And it gives you like a very CSS module-esque API where you actually have a link between your class name and the CSS file. Very nice. It's, of course, not all perfect. Because it has to be strictly typed and statically analyzable, there are some API decisions that the developers of vanilla extract make, like the media query. This is how you write a media query. It looks very JavaScript-y, but if you give this to somebody who is writing CSS, the syntax says it's a leap. this is not the most intuitive thing that I would come up with. I'd have to check the docs and then see, oh, this is how they do it, and because TypeScript, rah, 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 rah. So there's a bit of a jump there. So I started looking at other solutions where the API can at least remain the same. And the one I found was compiled by Atlassian Labs. And it's very interesting because they've tried to keep the styled components API, but compile it. Nice. I've figured out the timing, how long it takes to come back. But you can compile these out into a button.css. It basically just takes all of the CSS, pulls it out during compile time, and replaces the original with a generated class name. So the tech is very cool. I really like it. I tried to create a smaller prototype that's easier to read and easier to see what's going on. It's on my GitHub. It's called CSS-out.js. Get it? CSS-in-JS and CSS-out.js. The name is the best part about it. You can go through the code. It's pretty small. It's mostly to get an idea of how something like this would work with Babel. So success, right? This seems like a solution that could work. But of course, life is never that simple, because at GitHub, the main product uses SWC. It doesn't use Babel. So if you've ever wondered what would happen if you went further along the JavaScript, like if you started tipping off the scale, you'd actually reach Rust, right? So in the JavaScript ecosystem, you've got Parcel, you've got SWC, you've got ESBuild, which is actually Go, you've got Bun, which is in Zig. So you actually just fall off the cliff and get into different languages. So if you want to write a plugin for SWC, you have to write it in Rust, which is interesting. But at the same time, these 4K, it's OK, I can talk. These 4K components weren't built by one single team that's good with TypeScript. This was built across 20 sub-packages, as you'd imagine, across multiple teams. So React at GitHub, I would say, has been such a big success that more and more teams that were writing Ruby are actually writing React now. So we're building a lot of new things in React, which means that the next slide has a cute animation. I really wanted that. Oh, it's back. Perfect. A lot of the folks that were writing Ruby are now writing React. So they're used to this when they're writing styles, when they're writing CSS. The amount of JavaScript they expect is 0. And we're asking them to be here with us with very JavaScript crackhead energy on this side. And I think that's that's too big of a leap. So then I kind of changed the question from what's the right tool for the job to what's the right tool for the job for the people who actually need to do the job, which is a lot of the Ruby developers that have moved to the React side now. And also I have to acknowledge that it's not 2015 anymore. So all of these features that we got, a lot of these features are now natively supported. So variables, theming, CSS variables kind of changed the game. CSS nesting is actually supported in a lot of browsers. I didn't realize this until I was making the slides, that it's almost here. We're just waiting for Firefox, which is ironic, because Firefox was the first one to start the wave of this new CSS. Things have really fallen out. And then linting and imports, we've kind of got more CSS native tooling for them. So StyleLint, probably built in JavaScript, but really focuses on CSS. So we're not using something like ESLint or TypeScript to lint our code. We're using something built for the CSS compiler. Similar to PostCSS, you don't need to use JavaScript or Webpack for imports. You could actually rely a lot on PostCSS. So we could actually do with a lot less JavaScript. The only thing missing is an opinionated autocomplete. I couldn't find a single good way to get there fast. And while the diversity in JavaScript bundlers has really gone up, unfortunately, the diversity in code editors has really gone down. So if you're building something if you have to build an editor experience, you kind of can get away by just supporting VS Code. And VS Code would run in code spaces. It would run in Code Sandbox. It would run in Stack Blitz. Like a lot of these editors, online and offline, are built on top of VS Code. Sorry for the one WebStorm user in the room. sorry, not sorry. I don't know. I haven't tried. And there is precedence for a lot of this. So for example, this is from Tailwind. They have a really good IntelliSense extension that really fills, looking at your theme, it tries to figure out what would be a good value and fills it. This is from the VS Code extension for Shopify's Polaris. That's their design system. And in this screenshot, I'm trying to add shadow. And it's suggesting me the shadows from the system. So not just from all possible theme, but from their design system, the one they think is the right one. So I had a go at it. And I tried to do the same with Primer. And you can see here, it's suggesting things that are related to Primer, but also sorted by which one we want you to use. So if you're a developer at GitHub, we want you to use the ones that have a nicer name instead of the base ones. And if you do use a base thing, you also get some, I would call it linting. You also get some suggestions that you're using a base primitive, maybe use a functional primitive. This means nothing to the rest of you. I'm sorry. But I couldn't really find a good way of building this. That one, I did a lot of regex. There's a lot of hacky things. There's no good way to build opinionated autocomplete without learning about language servers. So that's a free open source idea for any of you. I think it would be fire. It's really popular. So success. Right now, clearly, we've gone far enough. We've dialed down on our JavaScript. Sorry, I just learned CSS finally. And then did the autocomplete, built some tools. But to remind you, we still have those 4K presentational components that we asked everyone to write in JavaScript with the SX prop. What do we do about them? How do we get all of them to CSS? Sure, the new code can be just CSS, but what do we do with the 4K presentation components? I guess we refactor them one at a time. That should take around 3 years, right? Or there was something that I showed you a few slides ago where we did play around with the idea of compiling styles out. Right? So the tech for that at least exists. And it might not exist in Rust, but it definitely does exist for Babel. And there's this really good tool called tsmorph. What tsmorph does is it looks at your TypeScript AST and lets you manipulate things with a script, essentially. So it doesn't have to be runtime. It doesn't have to be build time. It could be at the time the developer wants. So if you're doing a migration, you could do things like very smart things here. For example, you could look for JSX opening elements, JSX self-closing elements. And depending on the type of SX prop, so for example, if it's an object expression, that's the easiest, because you can just pull those out. But if it's something like an identifier, you can catch that. You can follow the identifier to its definition and then compile it out. If it's a call expression, if it's a function, then you can see where the function is defined, go into the contents of the function, compile those out. So even when on the runtime you call this function, it returns not a JavaScript object, it returns a class name that you can just pipe through. The only struggle with automation like this is that it's really bad at naming things, right? Which, I mean, same, but you have things like this where you have the file name, you have the container component, you have the component name, and then you can hash it. So you have a lot of tools to make the name really good in your automation. But most of my names kind of end up looking like this with a wrapper container stack hash. Because we've kind of gone onto this far where we've said names don't really, the class name doesn't really matter because you just put it on SX, and the component name doesn't really matter because you just wrap it with something else. So you get a lot of synonyms. Right? I think a code base like this is a good way to learn English, where there's like wrapper, container, stack is something else, but yeah. So instead of hoping for a completely automated migration, I think what's more likely is an automation-assisted migration, where you run the automation on a few files, maybe a page or two, and it gives you a lot of CSS, but the names aren't very good. And then you map those names to something that, as a human, you would come up with. So, and I think it's pretty timely in 23 that it's automation, it's humans assisted by automation to do the same work, but faster. Just call it AI, and I'm raising $2 million in seed funding. So, closing thoughts. Should you drop runtime CSS in JS as well? Yes, no, maybe. Um, you might be perfectly happy with your stack, and you might not have the same performance problems that we've faced. And if that's the case, and you have enough JavaScript developers to be on the point in the spectrum you are, well, then that's a happy place. Stay there. But if you did face the same challenges of performance or developer experience, but you're a team full of JavaScript crackheads, then go deeper, right? Go into this side, create a few bundlers, improve your own workflow. I promise it's really, really fun. But if you are a multidisciplinary team, that has designers and developers from different stacks contributing styles, then I recommend sliding all the way left and writing some CSS from scratch. I promise it's gotten really, really good. So that's all that I have. I really enjoyed that animation. I'm going to play it again. I spent at least 10% of this time making this animation. That's all I have. Thanks. Bye.